Hi, my name is Brian, and when designing an industrial control panel, one of the most important decisions is choosing the right cooling system. Select the right solution, and your components can operate reliably for years. Select the wrong one, and you may face premature failures, unexpected downtime, and unnecessary costs. In this explainer, we'll walk through how to move from guesswork to a more accurate, data-driven approach for selecting enclosure cooling. The challenge is not a lack of options. In many cases, the challenge is having too many options and not enough clarity on which one fits the application. Choosing incorrectly can become expensive very quickly. So, how do you avoid that? First, it helps to understand the financial risks. This is not just a technical detail for engineers. It is a business decision that affects reliability, maintenance, production uptime, and long-term operating costs. A poor cooling specification can create problems in two different ways. If the cooling system is undersized, the electronics inside the panel may operate at unsafe temperatures. Over time, that heat can damage components, cause failures, and lead to costly downtime. If the cooling system is oversized, you may spend more than necessary on the unit itself and the energy required to run it. Oversizing can also create condensation, introducing moisture inside the enclosure and putting sensitive components at risk. In either case, guessing is a risk. And that is why a data-driven selection process really matters. The right tool can take what feels like a complex engineering problem and turn it into a much more straightforward process. Instead of manually sorting through hundreds or even thousands of possible configurations, you can enter the key application details and generate a more precise recommendation. For example, from nVent Hoffman alone, there are more than 1,000 standard product configurations for enclosure climate control. Sorting through those options manually can be time-consuming and it increases the chance of choosing the wrong product. A selection tool helps reduce that complexity. It allows you to move from a broad list of possible products to a tailored recommendation based on your specific enclosure, environment, heat load, and power requirements. But any tool is only as accurate as the information entered into it. Accurate inputs are critical. If the information is incomplete or incorrect, the recommendation may not match the actual needs of the application. So, let's look at the information you need to have ready. The process starts with the enclosure itself. Before a cooling solution can be selected, the tool needs to understand the physical conditions of the cabinet. That includes the enclosure's dimensions, because size affects the available surface area for heat dissipation. It also includes any blocked surfaces, since areas against a wall or another panel may not release heat as efficiently. Indoor versus outdoor placement is another huge factor. For outdoor applications, solar loading can significantly increase the heat inside the enclosure. Even the color of the enclosure matters. A dark color enclosure in direct sunlight will absorb more heat than a lighter colored one. Power availability is also important. The tool needs to know what voltage and phase are available so it can recommend solutions that are practical for the installation. Once the enclosure details are entered, the next step is the most important part of the calculation: the internal heat load. The heat load is the amount of heat generated by the components inside the enclosure. Accurately determining this number is critical because it directly affects the size and type of cooling solution required. There are several different ways to determine heat load. If component data sheets are available, you can use the listed watt loss values. This is often the fastest and most direct method. If the panel is already operating and experiencing temperature issues, you can use real-world temperature measurements from the field. If the panel is still in the design phase, a component calculator can estimate the heat load based on the bill of materials. Each method supports a different scenario, whether you are troubleshooting an existing panel or designing a new one. After the data is entered and the calculation is complete, the tool will typically recommend solutions that fall into two main categories: open loop and closed loop cooling. Open loop solutions, such as filter fans, bring outside air into the enclosure to remove heat. They are simple, cost-effective, and work well in clean, dry environments where outside air is suitable for cooling. However, they are not appropriate for applications where the surrounding air contains dust, moisture, oil, chemicals, or other contaminants. Closed-loop solutions, on the other hand, such as enclosure air conditioners, keep the internal enclosure air separate from the outside environment. These systems typically cost more upfront, but they are often necessary when electronics need to be protected from dirty, wet, or harsh conditions. Closed-loop cooling also helps maintain the enclosure's NEMA or IP rating, which defines its level of protection against dust and water. The decision often comes down to a trade-off between lower initial cost and greater long-term protection. A good selection tool can handle most standard applications, but it is also important to recognize when a project requires additional engineering review. A tool is not a substitute for engineering judgment in every situation. For most common enclosure cooling applications, it can be extremely helpful, but complex or high-risk environments may require a deeper evaluation. Examples include hazardous locations, highly corrosive environments, extreme ambient temperatures, custom paint or finish requirements, unique airflow needs, or systems involving multiple enclosures. In these cases, the tool's recommendations should be treated as a starting point, not the final answer. An application engineer can review the details and help confirm that the selected solution is appropriate for the environment, the equipment, and the long-term reliability requirements of the system. Ultimately, enclosure cooling should not be a guess. It should be a calculated decision based on real application data. By using the right process and the right tools, you can turn climate control from a potential risk into a smart investment in system reliability. The choice is not just between a fan and an air conditioner. It is about protecting the components, reducing downtime, and supporting the long-term performance of the entire operation. Thank you for watching. If you enjoyed the video, make sure to leave a like and subscribe to Automation Nation. If you have any questions, drop them in the comments down below and one of our specialists will answer them. See you next time.